Hello everyone. In this video, I will cover section P2, in which we're going to study the integral exponents in scientific notation. So we start with the first definition, negative integral exponents. If A is a non-zero real number and n is a positive integer, then A to the negative n power equals 1 over A to the n. So let's look at an example. Let's say we have 3 to the negative 5 that's going to be equal to 1 over 3 to the 5th. So what is happening here is that the base of our power is 3 and the exponent is negative 5, and we can write this as a power with positive exponent 1 over 3 to the 5th. Here's another example. 2 to the negative 6 is going to be equal to 1 over 2 to the 6th. So again, recognize that the base of our power remains the same, but the exponent changes from negative 6 to positive 6. So let's say we have 1 over 5 to the 3rd. What is that going to be? 5 to the negative 3rd. So this is the first property of negative exponents. The next property is the rules of negative exponents and fractions. So in this case, we have if A and B are non-zero real numbers and M and N are integers, then the fraction A over B, all of it to the power negative N, is going to be equal to the fraction B over A, all of it to the power N. So what is happening here is that we are flipping the fraction A over B to B over A, and we're changing the negative exponent to positive exponent. And the other property is A to the negative N over B to the negative M equals B to the M over A to the N. So what's happening here is A to the negative N, let's work this out real quick. A to the negative N is 1 over A to the N over B to the negative M is 1 over B to the M. So then we have a fraction over a fraction, and we can write this as a product. So we have 1 over A to the N times B to the M over A to the N. So this, okay, I made a mistake here. B to the M over 1. So this will be B to the M over A to the N. So this is a property of powers when we work with fractions. So let's look at a couple of examples. So let's say we have 3 over 5 to the negative 2nd power. This is going to be, we're going to flip the fraction 5 over 3 to the 2nd power. Which we actually can write as 5 squared over 3 squared. Another example, 1 over 4 to the negative 3rd. This is going to be the fraction 4 over 1 to the 3rd, which we can write as 4 to the 3rd over 1 to the 3rd, which simplifies to 4 to the 3rd. For the second property, So let's look at an example on that. Four to the negative fifth over 3 to the negative 7. This is going to be 3 to the 7th. So look at the denominator. Becomes a numerator with a positive exponent, 3 to the 7th, over 4 to the 5th. Product rule. So the product rule is we're multiplying two powers with the same base. So here we have, if m and n are any positive integers, we have a to the m times a to the n equals, remember that a to the m is multiplying a to itself m times. So we have a times a times a m times. A to the nth power is multiplying a to itself n times. So we have a times a times a times a n times. So how many times are we multiplying a to itself? It will be m plus n. So when we're looking at the product rule, a to the m times a to the n equals a to the m plus n. Let's look at an example. 3 to the 5th times 3 to the 6th. This is going to be, I'm going to do this in a long way, but once we get used to the fact that we're multiplying number 3 5 times to itself, and by multiplying number 3 6 times to itself, we're actually multiplying 3 to itself 5 plus 6. So here we go. 3 to the 5th is 3 times 3 times 3 times 3 times 3, 5 times, 1, 2, 3, 4, 5, times 3 to the 6 will be 3 times 3 times 3 times 3 times 3 times 3, 6 times. And this will be 3 to, how many times are multiplying 3 to itself? 11th, which is 5 plus 6, so it's 3 to the 11th power. Let's say 5 to the 2nd times 5 to the 4th. Bases are the same, so this will be 5 to the 2 plus 4, so this will be 5 to the 6th. Let's look at third example. 4 to the 3rd times 7 to the 9th. All right, so can we multiply these two numbers, 4 to the 3rd times 7 to the 9th? Well, the answer is no, we cannot multiply these two powers because they have different bases. Remember when we looked at our example, let's say 3 to the 5th times 3 to the 6th, we're multiplying 3 5 times and 3 6 times, so that's why we could add the exponents. So in this case, we have 4. So this will be 4 times 4 times 4 times 4, 3 times, and then times 7 times 7 times 7, 9 times. Well, guess what? We cannot combine these numbers because 4 is different from 7. So the answer is still 4 to the 3rd times 7 to the 9. So we cannot combine these two powers. So the point I'm getting at is that when we multiply powers, so I'm going to put a star here. When we multiply powers. We use the power rule only when the bases are the same. The other property is the quotient rule. So the quotient rule is actually we're dividing powers. Okay, so we have a to be a positive number, and then m and n are positive integers. So if we divide a to the m over a to the n, that's going to be a to the m minus n. Again, notice here that the quotient rule applies base the same. So we'll look at an example. Let's say 3 to the 7th over 3 to the 4th. So the first example, I'm going to do it the long way, and then when we look at the pattern, we do not need to do the middle step. We can just subtract the exponents. But why do we subtract the exponents? So here's this example. 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. Let's see, I have 7 times 1, 2, 3, 4, 5, 6, 7. Okay, so that's the numerator. And the denominator is 3 times 3 times 3 times 3. So we're dividing the numerator by the denominator, and we can simplify common factors here. So this 3 will take away that 3, this one will take away that one, this one will take away this one, and this one will take away this one. So what are we left with? We're left with 3 times 3 times 3, which is 3 to the 3rd, which is the same as 3 to the 7 minus 4. So this is what the quotient rule is telling us. When we divide powers of the same base, we subtract the exponents. So another example, 4 to the 10th over 4 to the 7th. Recognize 4 and 4 is the base of the numerator and denominator. This is going to be 4 to the 10 minus 7. So this equals 4 to the 3rd. What if we have 3 to the 4th over 3 to the 6th? In this example, we have that the exponent on the numerator is lower than the exponent of the denominator. Well, if we use the quotient rule, this is going to be 3 to what exponent? 4 minus 6 equals 3 to what power? Negative 2. And using the negative exponent property, this is going to be 1 over 3 squared. So you're going to look at the pattern that when the numerator is less than the denominator, we're going to have the positive power in the denominator. So we have 1 over 3 squared. Positive power in the denominator. Let's look at another example. 5 to the 3rd over 7 to the 4th. Equals. Can we divide these powers? Well, recognize that the base and the numerator is 5. The base in the denominator is 7. So we cannot simplify these powers. Cannot divide. The next property is the power of the power rule. So what is this saying is that if I have a to the m, a to the m, to the nth power, we end up having another power where the base is a and the exponent is m times n, so we're multiplying the exponents. So let's look at an example here. So what we're saying is if we have 3 squared, all of this to the 5th power, what is this going to be when we simplify this? Well, by the order of operations, we do the operation inside the parentheses first. So what we're going to have is 3 squared. What is 3 squared? That's 3 times 3. All of this is to the 5th power. So recognize that we have 3 squared is 3 times 3. So now we're going to have 3 times 3 to the 5th power. So that's going to be 3 times 3, here's 1, times 3 times 3, here's 2, times 3 times 3, here's 3, times 3 times 3, here's 4, times 3 times 3, here's 5. So what we're having is 3 times 3, 5 times. 1, 2, 3, 4, 5. So at the end, we're multiplying 3 how many times to itself? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 3 to the 10th power, which actually would have been 3 to the 2 times 5. 2 times 5 right here, which is 3 to the 10th. So here we go, 3 to the 10th, 3 to the 10th. So bottom line is when we multiply, and let me track this, the bottom line of the power over the power rule is that if we have a power over the power, we multiply the exponents. Let's look at another example. 4 to the 3rd, all of this to the 5th equals, we take the base 4 to the exponent 3 times 5, so this equals 4 to the 15. This is what power over the power rule says. The other property is power of a product rule. So what do we have here? If I have A times B as a quantity to the nth power, each product on the base is going to be raised to the nth power. So this equals A to the nth times B to the nth. So let's look at an example. 3 times 2, all of this to the 5th power, equals 3 to the 5th power times 2 to the 5th power. To the 5th power. Let's get another example. A times y to the 4th equals A to the 4th times y to the 4th. Next, we're looking at power of a quotient rule, which is an application of power of a product. So similar to what we did in the previous example, if we have A over B, all of it to the nth power, we're going to have A to the nth power over B to the nth power. So let's look at an example here. 4 over 3 to the 6th power. This equals, we're going to have a fraction. So we're going to have the numerator to the 6, which is 4 to the 6 over 3 to the 6. And the last concept on this lecture is scientific notation. So in scientific notation, a positive number is written as a product of a number between 1 and 10 and a power of 10. So let's look at an example. What this means is a number written in the form 2.34 times 10 to the 6. So this is in scientific notation. So we're looking at a product of a number between 1 and 10. So this is the number they're talking about. 2.34 is a number between 1 and 10. The number between 1 and 10. And multiplying by a power of 10. So this is the power of 10. So another example. 3 times 10 to the negative 4th. So here's the number between 1 and 10, and here the power of 10. If I'm looking at an example like this, 36 times 10 to the 3rd. Is this in scientific notation? Let's pause for a moment. In the definition of scientific notation, we want a product of a number between 1 and 10. Well, in here we do have a product of a number, which is 36, and then multiplying it by 10 to the third. Is 36 a number between 1 and 10? No. Therefore, this is not in scientific notation. 3 is not in scientific notation. Okay? But every number, every real number can be written in scientific notation. So how can we write 3 in a scientific notation? Well, in scientific notation, this would have been 3.6 times a power of 10. 10 to what power? So notice that 36 I wrote as 3.6. So 36 is 3.6 times 10 to the first. So if you multiply 3.6 times 10 to the first, it will give us 36. So this is the 36 number. And then we're multiplying this number by 10 to the third. So to combine this in a scientific notation, we're going to have 3.6 times 10 to what power? 4. Okay, I will stop here for this lecture, and shortly I will make another video with exercises from the homework, so we see how we apply these properties in the homework for section P2.